Well, now, since we have covered the case of different real roots, different complex roots, and a repeated real root, so the question is, please try to figure it out by yourselves, what we shall do, how we solve a second order differential equation in case when the corresponding characteristic equation has a repeated complex root. All right? And you are welcome to share your ideas via the online discussion board. Okay, now let us continue. So everything until now was about differential equations where the right hand side is 0. So they look like a double prime plus by prime plus cy is 0, right? So the right hand side is 0. So these are homogeneous equations. And now you have your general theorem, which I'm not going to prove because it is exactly like in linear algebra. So in order to get the general solution of a non-homogeneous equation, you need to take any specific solution of the non-homogeneous equation. And then you need to add the general solution of the homogeneous equation, right? So let me write it. So y equals a particular solution of the of this equation plus the general solution of the corresponding homogeneous equation plus the general solution of the corresponding homogeneous equation. And here is an example. So notice that here the coefficients of these differential equations are not constant, which means that strictly speaking we do not have a method to solve it. But since I invented this example, I know that when I invented it, I had what I had in mind is that its solutions are going to be powers of t. And if you know that, then you can guess that there exist two linearly independent solutions that are square and cube respectively. Yeah, if you remember your first problem set on week 2, you had application exercises and there was this application exercise 10. Yeah, it was exactly about the same thing. So you had to guess solutions of the form t to the r. Well, anyway, so suppose that somehow we guessed, or we just know that that there are the two linearly independent solutions of the corresponding homogeneous equation. So then we need to find any particular solution of this non-homogeneous equation. And the idea here is that you just stare at it and notice that the right hand side is a constant, which means you can try the left hand side to be a constant because the derivative of a constant is 0. So if your y is a constant, then this part just disappears, and then you have 6y equals 1, so which is easy, y equals 1 over 6. And then it means that the general solution of the non-homogeneous equation is going to be this particular solution, which is 1 over 6, plus the general solution of the corresponding homogeneous equation. So this and this. So let me emphasize again that this structure theorem works for all kinds of second order differential equations, homogeneous, constant coefficients or non-constant coefficients, doesn't matter. It's just that if the coefficients are non-constant, then generally speaking we do not have a method to find two linearly independent solutions. Well, so then there is a kind of a trick that to discover. So suppose that we know how to solve the homogeneous equation, right? So if we know this part, if we know the two solutions of the homogeneous equation, the question is there a method to find a particular solution of the non-homogeneous equation? And there is such a method. There are even two methods. So the first of them is called the method of undetermined coefficients, and basically it is guessing. The problem with it is that sometimes it doesn't work. It only works when the right-hand side of the differential equation has a particular nice form. So for example, whenever it is a polynomial, or when it is a combination of exponential functions and trigonometric functions, then the method of undetermined coefficients is going to work. But if the right-hand side contains something like, let's say, inverse trigonometric functions or logarithms, then it fails. And another problem with the method of variation of parameters is that it's kind of a guessing. So there is a bit of an art in when you use it. It's not a well-structured algorithm that you can apply and produce an answer for sure. So, but if it works, then it works very quickly. It is, strictly speaking, it is, if it can be done, then it can be done much quicker than the variation of parameters. So variation of parameters is slower, but since we are mathematics students, I'm going to teach you the general method of variation of parameters, and the method of undetermined coefficients will not be taught in class. But of course you are welcome to read about it in the textbook, and so to test your understanding you can try to find the general solution of this differential equation and post it on the online discussion board.